Okay, so this is homework 9, problem 8. The problem states a 57.6 kilogram keg of beer slides upright down a 3.15 meter ramp or long plank leading to the back of a truck that is 1.1 meters high to the ground. Determine the amount of work done on the keg by gravity. So our setup should look something like this. We have that's a bad truck, but imagine that's a truck. This is the truck's tailgate, and there's a ramp leading up a certain way, and then there's a keg of beer on this ramp, okay? And that ramp has a height of 1.1 meters. And the keg has a mass of 57.6 kilograms. And this ramp has a length of 3.15 meters. So it says, what is the work of gravity on the keg? Okay. So work is equal to force times displacement. And so if we draw a free body diagram right here, what are the forces acting on this keg? Well, we have the weight force, mg. We have a normal force, right, from this plank or this thing pushing on the keg. And then our displacement is actually going to be from here down to the truck bed, right? So our displacement is going this way. So, at this point, mg is not pointed in the direction of the displacement, right? Or at least part of it is, but the other part is not. And what I mean by that is that this weight vector can be broken down into two components. So we have normal force, we have mg. Well, this mg can be broken down into its two components, right, at a right angle. So what is this component here of mg? Well, first, we don't necessarily know the angle, but this we're going to just say is theta, okay? And so if our mg is pointed directly down here, and our normal force is pointed this way, then we have a force pointed here, a portion of mg, and we have a portion pointing this way, right? So if this is theta, then that means this angle here has to also be so like 20, that means this would be 70. Yeah, so this has to be theta, right? So just imagine a scenario where this was, let's just redraw it. Same scenario, we have mg pointed down, we have the normal force, and we have this mg is broken into its components, kind of like that. Say if this angle here was 20 degrees, right? This is supposed to make a right angle. Actually, let's just redraw here. mg, force normal. So this is our ramp. If this angle here was 20 degrees, then if this is a right angle, that means this angle here has to be 70 degrees. And if this whole thing is a right triangle, if this is 70, this here has to be 20. So this angle here is theta, and it's the same theta as this angle here. So this angle here has to be theta. So how would we describe this component here? If this is mg, this is opposite, so this must be mg sine theta. And this is adjacent to the angle, so this is mg cosine theta. So, going back to our problem here, we're looking for work done by gravity. And where's our displacement? Our displacement is going down the ramp. So our displacement is from here to here. This is our displacement. So which one of these forces is acting in that same plane as the displacement? Well, it's not the normal force, because displacement's going this way. Normal force is perpendicular. It's not mg cosine theta, because that's also perpendicular. The only one that's acting in that displacement vector is mg sine theta. So work equals force over displacement. The force is just mg sine theta. The displacement it gave us was 3.15 meters. So the mass of the keg was 57.6. 9.8 times the sine of theta times 3.15 meters is equal to the work done by gravity. Right this moment, we don't know what theta is. So let's go back and figure what it is. So if we have a right triangle, we redraw our little guy. We're looking for theta. We know that this height was 1.1 meters. We know that this length of this ramp was 3.15 meters. So theta, we can do sine theta is equal to opposite over hypotenuse. And we can say theta is equal to the inverse sine of 1.1 over 3.15. 1.1 divided by 3.15. And we take the inverse sine of the answer. So that gives us a theta of 20.44 degrees. So we can plug that in for the theta because we just solved for it. So 57.6 times 9.8 times sine 20.44 times our displacement. That should give us a 620.9 joules, and that is the work done by the gravitational force.